4.1, part 2, doing a cone problem. So here's just a way I will blindly set myself up to do any cone problem before I even look at the specifics of the problem. I'll draw myself a little triangle and put an X on it and a Y on it just so I have that to look at. I'll draw another triangle of the same orientation that I'm going to use to write some ratios, meaning like cross multiplication stuff in a second. I'm going to do another triangle where I put some actual numbers from the actual story that are valid at a certain moment in time in the story. And we'll come back to that in a second. The formula for this is always V equals 1/3 pi x squared y. This is a pain of a formula because there's two variables and they're both changing. This is not like the cylinder. Cone's not like a cylinder in the sense that if you have a cylinder, it has a radius that's measurable and it has a height. But if we start draining water out, what's going to change? We've got a radius, we've got a height. We drain the volume will change. But if we drain out water, the volume will change. But which of the variables will change, radius or height? The height. The radius won't change. But if we have a cone, and I don't have a cone in the room, you know, you've got a snow cone kind of cone, and you start draining water out of it. It also has a radius, it also has a height. What's going to change as the water drains? The height and the radius. Because as the cone drains, the circle keeps shrinking on down. So there's going to be more work to do on these cones because you're going to have a couple things changing simultaneously. So I just get this ready. Before I even read the question, I just work through this. Example 4, we'll read and see what are the specifics of this cone question. They say, water is running into a conical tank at a rate. Okay, rate is a code word, synonym word for what are rates measured with in math now. Rates are derivatives. So water's running in at a rate of 9. So like d something is 9. And since the water is running into the tank, that rate should be positive or negative? Positive, because we're increasing the amount of water. If the water were being drained, we would go a negative rate on that. The tank stands point down. If it's filled, it has a height of 10 and it has a radius of 5. It isn't going to be filled at any point in this story. It's getting drained or filled or changing or whatever. But if it were a full cone, it would have a height of 10, base of 5. So I'm going to go height of 10, radius of 5. If they said it had a diameter of 5, I wouldn't have just written a 5. What would I have written if they said that the diameter was 5? Half of that, 2.5. I'm going to use this to write some ratios in a second. This one they were artificially kind to you because 5 is half of 10, so that's going to simplify our math life to a degree. That means the radius would always be half of what the height is. So a full tank of 10 height would have a 5 radius. If we drained it so it had a 8 height, it would have a 4 radius. If it were 6 high, it would be 3 across. They could have been meaner, and some of the homework questions might be meaner, like if this is an 11 and this is a 7. Like the math doesn't come as easy. It's not as common sense. It can still be done, but it's going to have us doing some cross-multiplying in these questions sometimes. They say at this moment the water level is 6 feet deep. So that's an actual number. Right now, the actual height is 6. So the actual radius, we might as well just do it, would be 3. If this were harder math, like if I went with 11 and 7 and 6 and mystery, you'd have to do something like this. So if I want to call this A, if I want to do a setup to just solve for that, I could put A over 6. If I do A over 6, that would equal 5 over 10. Cross multiply and get it, no matter how weird the number would be. You could get a fraction or decimal or whatever you want to get. You could have also done A over 5. If you do A over 5, it would equal 6 over 10. There's not one right way to set up your cross multiply. You do what you need to do. But if it's so simple, it's just common sense. 5's half a 10, so 3's half a 6. Go for it. Just be aware in some of the homework problems, you're going to have to set up a proportion problem and cross multiply it to get that number, and it won't come out clean like a whole number all the time. Question about that? So here's our situation then. This will be the equation you use every time. What negative would you have? And I don't mean negative like positive negative, I mean negative like we don't like it. What negative do we have about doing the derivative of this equation right now as it exists? It'd be fraction still is bad. There's a worse thing than that. It has to do with these. Oh, you'd have to do the product rule. So it would be a monstrous big product rule you'd have to do. It would have fractions in the product rule, pies in the product rule, lots of stuff like that in the product rule. So I have a workaround for that. So this is our workaround for that is I would like to, instead of having two variables, which is going to cause us the product rule, let's do a little bit of algebra and get it down to one variable. So I'm going to use my ratio triangle with my XY thing that I can look at to try to just get a replacement made. I'm going to prefer to replace the Y. Y will be easier to replace because if I replace the X, I'm going to have to square it. Like, I don't know, why add any level of complication? So I'd like to get the Y, like a Y equation. So I'll put a Y on top where it's easier to solve for. And I could go Y over who? Y over X is fine, also acceptable, Y over 10, doesn't matter. If we go Y over X, that equals 10 over 5. If we want the Y alone, Y would equal 2X, which means we can put this 2X in Y's spot, and we have a better volume equation now. The volume would equal not 1/3 but 2/3, because 2 times 1/3, we can interact those numbers, still a pi, and X would now be the third power. I think you'd agree with me, you would much rather do the derivative of this than a product rule derivative of that. And it's worth paying the price of a little bit of cross multiply move to just get that done. Question to there? Now it's sort of standard. Okay, we're going to do the derivative. So dv dt, derivative of this would be 2 pi x squared dx over dx dt. I don't have quite the list that I had the other days. This sort of is my list. The actual 3 is x. The actual 6 is y. What D thing could I label? What was that 9 rate? That's the rate of change of who? Choices would be X, Y, or volume. Volume. So let's plug in. So this could be re-represented by 9. 2 pi. The x was 9. Once you square it, we've got a 3 squared, which is a 9. And then dx dt is what we don't know, and that's what we want to try to solve for. 3 squared is 9, so when we divide that into 9, that's 1. And the 2 pi on the bottom. And there's half the answer.
Okay, wait, where did you get the 3 from?
The actual x
Oh. Okay.
is in the x position.
Okay, yeah.
Instead of making a list, I just look more at my pictures on it. Question there? Other thing we want to figure out is dy dt. There's a really long way and a really short way to figure that out. Can anybody think of a way that you could figure out dy dt?
Do the derivative of the y equals 2x.
That's the quick way. Can you think of a long way?
Do go to the v equals 1/3 x or pi x squared y and do the derivative of that.
Maybe we'd have to product rule and that would be a pain. Long way would be do one of these cross multiplies to also get an x equals. Replace the x thing there with the y thing that x would equal and essentially repeat the process. But that's not necessary. Since we know y equals 2x, if we do the derivative, dy dt would be 2 dx dt. And we just figured out that dx dt was this fraction. So this fraction times the 2, the dy dt could be 1 over pi. That's the quickest way to accomplish the mission there at the end. The cone problems are all the same, so that's kind of nice. The only way they do any modifications on the cone is they'll sometimes mention diameters, not radii, and then you've got to do a little halvesy move and notice that happened. Question about cones? The next homework's not exclusively cones, it's just there are some cones. So but we're same page, we're just continuing to do whatever problems the syllabus says. So we can cut the video and then we'll just talk about if there's